Welcome guys to another exciting episode of Amax Tutorials. Today we'll be looking at an interesting topic in business mathematics. Today we'll be looking at the determinants of a 3 by 3 matrix. It's not that different from the determinant of a 2 by 2 matrix, just that for this particular 3 by 3 matrix, we are going to deal with minus and cofactors. So let's take this particular example and solve it together. So assuming we have this matrix A, which is 1, 2, 0, 3, 9 minus 2, 7, 12, and 6. So assuming we have this 3 by 3 matrix, that's 3 rows and 3 columns. Assuming we have this 3 by 3 matrix and we are asked to find the inverse of this particular matrix. Now these are the steps that you are to follow or you are to go through before you can find the inverse of this particular matrix. You first have to find the determinant of this particular matrix, which is matrix A. After that, you create the minus of the matrix, then you create the cofactors. That's you find the cofactors of the minus that you created. Then you transpose the cofactors to find the adjoint or the adjugate of the matrix. Then you multiply the 1 over determinant by the adjugate. That's the inverse of a matrix. That's the formula, which is given as inverse equals 1 over determinant of the matrix times the adjoint or the adjugate of the matrix. Now, as the formula goes, we have to first find the determinant of this particular matrix. Now, before you find the determinant of a 3 by 3 matrix, it's not that different from the determinant of a 2 by 2 matrix, but it's a little bit confusing. When finding the determinant of 3 by 3 matrix, we first have to create the minus. How do we create the minus? We first have to mentally delete the first row of the matrix and the first column of the matrix. So we are going to delete the first row mentally. So we have to cut this first row and the first column out to create the first minus. So after deleting the first row and the first column, we are going to be left with 9, 12, negative 2, and 6. So we have 9, 12, negative 2, and 6. So we've created our first minor. We are going to use this first minor to find the determinant of the matrix. After that, then we create another set of minors to also aid us in finding the cofactors. So we create our first minor, which is 9, 12, 6, minus 2, and 6. After that, we first mentally deleted the first row and the first column. Second one, we first mentally delete the first row and the second column. So after deleting the first row and the first column, you are not done. You're also going to delete the first row and the second column. So if you mentally delete the first row and the second column, we are going to be left with 1. So we are going to be left with 2, 12, 0, and 6. So we have 2, 12, 0, and 6. That's the second minor. So we are going to name this as minor 1, 1. Then this is our minor 1, 2. So we are going to create our third minor. That's minor 1, 3. Which is then we are going to mentally delete the first row again. So this first row will go again and the third column. So we are going to go this way, first row and third column. It will be left with 2, 9, 0, and minus 2. We are going to have 2, 9, 0, and minus 2. Now, after finding your minus of this particular matrix, you then multiply each minor by the first element of the matrix. So you are going to multiply the minor 1, 1, which is 9, 12, negative 2, and 6, by the first element, which is 1. Then you multiply the second minor that you created by 3. So in this one, we are going to negate the middle one. In the video, I'm going to explain why we negated this particular value, that's 3, and not also we didn't negate 1 and the other one. So we are going to have minus 3, then you add 7, which is the third element of the matrix to the other one. So we are going to find the determinant of this particular matrix, and the determinant of the third matrix. So after that, you multiply by the element that it is in front. So we are going to have this 1 multiplied by the determinant of this. So determinant of this is going to give us 9 multiplied by 6, 12 multiplied by minus 2, minus 2 multiplied by 6, 12 times 0, plus 7, which is minus 2 times 2 minus 9 times 0. So we are going to find the determinant of the matrix. So 9 multiplied by 6 gives us 54. So we have 54 here, minus 12 multiplied by 2 will give us 24. So minus will give us plus 24. Then you go to the second one, which is minus 3 multiplied by 2 multiplied by 6 gives us 12, times this gives us 0, plus 2, this gives us minus 4, which is 7 minus 4 minus this gives us 0. So we then find 54 plus 20, 24 gives us 78, multiplied by 1 gives us 78. This gives us 12, multiplied by 12 gives us 3 times 12 gives us 36. So we have minus 36. 7 times 4 gives us 28. So we have minus 28. After that, you do your calculation, which is 78 minus 36 minus 28, which gives us 14. So determinant of this particular matrix is 14. So determinant of A is 14. We are not chasing or we are not after determinants of the matrix, but we are to find the inverse of this particular matrix. But before you find the inverse of the matrix, you first have to find the determinants. After that, you divide the determinants. You have 1 over determinant, then you multiply by the adjugate of the matrix. But here is the case we are dealing with 3 by 3 matrix. That's why we are going through all this process. It's not like the normal 2 by 2 matrix, which we are going to just find the determinants, then you go your way. So after finding your determinant, let's say you find the determinant. After that, you create minus of the matrix. How do you create the minus? As I said, when you have to create the first minus, you first have to mentally delete the first row and the first column. So the first minus that you created was minus 1, 1, which is 9, 12, negative 2, and 6. So you mentally deleted the first row and the first column. Then the minus 1, 2 gave us 2, 12, 0, 6, which we deleted first row and the second column. After that, minus 1, 3, which gave us 2, 9, 0, minus 2. First row, third column. We are done with the first, the first row. Now we move to the second row, which is 2, 9, 6. So here you are going to mentally delete the second row and the first column to create your minus 2, 1. So let me write the values here so that you will not be confused. We have minus 1, 1, which is 9, 12, minus 2, 6. Then minus 1, 2, which is 2, 12, 0, 6. Then minus 1, 3, which is 2, 9, 0, 2. So this is the minus that we've created. We are now coming to the second row and the first column. So you mentally delete the second row and the first column. So if you mentally delete the second row and the first column, we are going to delete this one and the second column. So we'll be left with 3, 7, minus 2, and 6. So we have our minus 2, 1, 2, 3, 7, minus 2, and 6. Now we move to minus 2, 2. You would mentally delete the second row and the second column. You mentally delete the second row and the second column. So second row and second column. It gives us 1, 7, 9, 6. Sorry, 9, 7, 0, 6. So we have this, and that. So we have second row and second column. Second row and second column. So we have 1, 7, 0, 6. Sorry, minus 2, 2. We have 1, 7, 0, 6. Then we have minus 2, 3, which also gives us mentally delete the second row and the third column. Mentally delete the second row and the third column. So we will be left with, so it goes this way, this and that. So we go this way and we go that way. So we have 1, 3, 0, 2. 1, 3, 0, minus 2. So 1, 3, 0, minus 2. You are not done. You remember you first dealt with the first row, then you move to the second row. So now we are moving to the third row. So you mentally delete the third row and the first column to get your minus 3, 1. So third row and first column will be left with. So this way, that way. So you get 3, 7, 9, 12. We have 3, 7, 9, 12. Then you move to minus 3, 2. Third row, second column. So we have 1, 2, 1, 7, 2, 12. Third row, second column. So we have third row and second column. So we have your 1, 7, 2, 12. So we have 1, 7, 2, 12. Then our last minor, which is minor 3, 3, which is third row, third column. So third row, third column. Then we'll be left with 1, 3, 2, 9. 1, 3, 2, 9. So we are done creating our minus. The formula says that after you've created your minus, you then use this minus to calculate for the cofactors. So we are about to create our cofactors for this particular minus. So we are now going to create our cofactors for this particular minus that we've created from our matrix. That's the matrix A. But before then, let me write this here for us to see how we are going to represent the cofactors in the matrix. So assuming this is our cofactor matrix, we are going to represent minus 1, 1, minus 1, 2, minus 1, 3, minus 2, 1, minus 2, 2, then it follows 2, 3, minus 3, 1, 3, 2, then minus 3, 3. So this is how we are going to represent the minus to get our cofactor. But before that, we have to find the cofactors for each minus that we've created. So how do we then find our cofactor? Cofactor is a sign minus. So assuming this is our cofactor, this ij, cofactor is equal to -1 raised to the power I plus j multiplied by minus. So this I represents the row and the j represents the column. So the mij here is the minus that we are talking about. So if you want to find this particular cofactor, if you want to find the cofactor for this particular minus, you are going to substitute in this into that. So you first have to find the determinant of the minus. After that, you input the determinant in here to get your cofactor. It's not that difficult. You just have to, pay attention and get the understanding. So you first have to find the determinant of this particular minor. After finding the determinant of this particular minor, you substitute the determinant into this bracket. So we are going to have, so assuming this is our minor. So we are going to find our cofactor for this particular minor, which is cofactor 1, 1. So we have cofactor 1, 1. And the formula goes by cofactor ij equals -1 I plus j multiplied by minus. So you have to find the determinant of this particular matrix or this particular minus. And determinant is by multiplying the principal diagonal, which is 9 and 6. Then you subtract the other diagonal, which is 12 and -2 from the principal diagonal. So you multiply your 9 by 6, which is the principal diagonal, you get 54. So we have 54 minus 12 times 2 gives us 24. So negative gives us plus. So we have our 24. So our determinant for this particular matrix is 78. So 78. Now we substitute in 78 at this side. Remember we are finding or we are chasing after cofactor. But before you find the cofactor, you first have to find the determinant of the minor. So after finding the determinant, which is 78, you then substitute in here. Remember this 1 1 has been represented here. That's the ij. This is the row and the column. So we have cofactor, which is cofactor 1 1 to be -1, which is constant here. We have our ij, which is 1 and 1 here. So 1 plus 1 multiplied by the determinant of this particular matrix, which is 78. So this one gives us 2. So we have cofactor 1 1 to be equal to -1 raised to the power 2 multiplied by 78. And you know that -1 raised to the power 2 is +1. So 1 multiplied by 78 gives us 78. So the cofactor for this particular matrix, which is -1 1, is 78. Cofactor is 78. 78. Now we move to the second one. That's the -1 2. Same approach. You find the determinant for the particular minor. Then you insert it in the formula. So we have 2 multiplied by 6 as our determinant. Then 12 multiplied by 0. So we have here to be 12. 2 times 6 will give us 12. This gives us 0. So we have our determinant to be 12. Now we insert it here. We have -1. We have 1 and 2. Don't forget that we have moved to -1 2 and not 1 1. So we are going to change the values. We have 1 2. So we have 1 plus 2. Then the determinant, which is 12 here. Now negative. If you add 1 plus 2, you are going to get 3. -1 raised to the power 2. -1 raised to the power 3 gives you -1. So -1 multiplied by 12 gives you -12. So we have our cofactor 1 2 to be -12. -12. Then you move to the cofactor for -1 3. Cofactor for -1 3. So cofactor, same approach. You multiply 2 by -2, which gives us -4. Then 0. You insert it here. -1. 1 plus 3. Determinant, which is -4. So we have this to be +1, then -4, which gives us a cofactor of -4. So cofactor 1 3 equals -4. Move straight away to the cofactor 2 1. 3 times 6 gives us 18. 7 times 2 gives us 14. Minus gives us plus. So 18 plus 14 gives us 32. So we have 32 to be our determinant, multiplied by -1, 2 plus 1. So we have -1 multiplied by 32, which gives us cofactor 2 1 to be -32. Then we move to cofactor 2 2. So cofactor 2 2, same approach. 1 multiplied by 6 gives us 6, minus 7, which is, okay, 0 times 7 gives us 0. So we are going to have the determinant to be 6. We have our cofactor formula here. So -1, 2 2. So 2 plus 2 gives us 4, multiplied by the determinant of the cofactor. The -2 2, which is 6, gives us 4, -1 raised to the power 4, which is positive, times 6, gives us cofactor 2 2 to be +6. Now cofactor 3 3. I hope you are getting what I'm doing. Cofactor 2 3 is multiply the principal diagonal, which is -2 times 1 minus 3 times 0. So we have -2 minus, we have 0. So our determinant for -2 3 is -2. You insert it here. We have -1, which is 2 plus 3 here, multiplied by the determinant, which is -2. So we have here to be 5. -1 is the power 5, which is negative, multiplied by -2. So negative gives us positive. So our cofactor here is +2. So cofactor 2 3 is +2. Now I move to the -3 1. That's our last part. -3 1. So 3 multiplied by 21, which is 63. We are finding that determinant, which is 63. Then 9 multiplied by 7, which is 60. We have 3 multiplied by 21 here, which is 63. 3 multiplied by 21, which is 63, and 7 multiplied by 9, which is also 63. So we have our determinant to be 0. So you insert it here, minus 1, 3 plus 1, multiplied by the term, which is 0. Obviously, we are going to get, this one gives us minus 1 to the power 4, multiplied by 0, gives us cofactor 3, 1 to be 0. Now move to the cofactor 3, 2. Find our determinant, which is 12. 1 by 12 gives us 12. 7 by 2 gives us 14. So 12 minus 14 gives us minus 2. Determinant is minus 2. So negative 1. Cofactor 3, 2. 3 plus 2. Determinant of minus 2 gives us minus 1 multiplied by negative 2, which is positive 2. So our cofactor 3, 2 is 2. Then the last one, which is minus 3, 3. Minus 3, 3. We have negative 1 multiplied with the power 3 plus 3, which gives us 6, times the determinant. 9 by 1 gives us 9. Minus 3 by 2 gives us 6. So 9 minus 6 gives us 3. So our determinant is 3. This gives us positive 1 times 1 gives us positive 3. So our cofactor 3, 3 equals positive 3. Remember, I did some arrangements here, which, let me write it again. Let me write it. So we have here to be minus 1, 1, minus 1, 2, minus 1, 3, minus 2, 1, minus 2, 2, minus 2, 3, minus 3, 1, minus 3, 2, then minus 3, 3. So we are going to represent this whole thing by the cofactors that we find it here. Remember, this is the this is the minus. So, but we've transformed this minus into cofactors. We are going to represent this by the cofactor 1, 1. This by cofactor 1, 2, cofactor 1, 3, cofactor 2, 1, cofactor 2, 2. Then it follows. So if we are to represent this in a matrix form, this cofactors in a matrix form, we are going to have, let me clean the formula. We are going to have this cofactor of matrix A. This is how we write it. Cofactor of matrix A. Cofactor. So let me write it this way before. Cofactor 1, 1, cofactor 1, 2, cofactor 1, 3, cofactor 2, 1, cofactor 2, 2, cofactor 2, 3, cofactor 3, 1, 3, 2, then cofactor 3, 3. Then we have our cofactor of matrix A to be. You know cofactor 1, 1 to be 78. Cofactor 1, 2, which is here, is minus 12. Cofactor 1, 3, which is minus 4. Cofactor 2, 1, which is minus 32. Cofactor 2, 2, which is 6. Cofactor 2, 3, which is 2. And cofactor 3, 1, which is 0. Then cofactor 3, 2, which is 2. Then cofactor 3, 3, which is 3. Now that we know our cofactor, which has been represented here. Now, the step says that after finding your cofactor, you now transpose the cofactors into. So we now transpose the cofactor to find your adjunct or adjoint. So the transpose is basically writing all the rows as columns and all the columns as rows. So if you write this row as column, we are going to have 78 minus 12 and minus 4. Then the second row, you write it as column. Third row, you write it as column. So the transpose of this particular matrix, which is this. So let me write it this way. Adjoint or adjunct equals the transpose of the cofactor, which is C. So the transpose of the matrix, this equals, you write the rows as columns. So we have 78 our first element, minus 12, minus 4. Then we have minus 32, 6, and 2. we have 0, 2, and 3. So this is how we transfer cofactor into how do you call it, adjoint. That if you are finding for adjoint, you just have to transpose the cofactors to get your adjugate or adjoint. So transpose of a matrix is basically rewriting the rows as columns and columns as rows. So this is the adjoint or adjugate of this particular matrix or this particular cofactor matrix. After finding your cofactor, the next step is you multiply the determinants. That's the 1 over the determinants by the adjoint of the matrix. And this is the formula for finding for inverse of a matrix. Remember, we have to find the inverse of the matrix. That's the 3 by 3 matrix. So we have our formula to be 1 over determinant of A times the adjugate or adjoint of A. Or you can have it as adjoint of A all over determinant of A. Either this or that, you get the same answer. Remember, our determinant for the matrix A is 14. So we have our 1 over 14, which is 1 over determinant, multiplied by the adjoint, which is 78 minus 32, 0, minus 12, 6, 2, minus 4, 2, and 3. So now you multiply the 1 over 14 by each element in the matrix. So if you multiply 1 over 14 by 78, you are going to get 39 out of 7. If you multiply 1 over 14 by minus 32, you are going to have minus 16 out of 7. And obviously, you are going to get 0 for the tail elements. 1 over 14 times minus 12, we have minus 6 out of 7. 1 over 14 times 6, we have 3 out of 7. 1 over 14 times 2, we have 1 out of 7. We come back to minus 4 times 1 over 14, we have minus 2 out of 7. 2 times 1 over 14, we have 1 out of 7. Then 3 times 1 out of 14, we have 3 out of 14. So after finding this, so this is basically how we find the inverse of a 3 by 3 matrix. So this is the inverse of the matrix. So the inverse equals this. That's the inverse of the 3 by 3 matrix that we were asked to find. So this is the answer for the inverse of the matrix. This is the answer for the inverse of. That's all for today's lesson on AMAX tutorials. If this video helped you, kindly like, subscribe, and share with your friends. See you in the next video. Thank you.